Friends, welcome to the class. Today we'll discuss about fundamental theorem of arithmetic. According to fundamental theorem of arithmetic, every composite number can be written as the product of prime numbers. In other words, any integer greater than 1 either be a prime number or can be written as the product of prime numbers. Now the question comes, what is prime numbers? And if any number can be expressed as the product of prime numbers, what is the nature of that particular number is all about. Let's understand in detail. Prime numbers. A number is called prime if it has no other factors other than 1 and the number itself. For example, 2, 3, 5, 7, 11, 13, 29, 43, 87, etc. See, all these numbers, they have no other factors other than the number itself and 1. Neither 5 nor 13 nor 29 can be divided by any other numbers. Composite numbers. A number is called composite numbers if it has at least one factor other than 1 and the number itself. For example, 4, 6, 9, 12, 20, 35, 63, etc. See, in all these cases, 4, 6, 9, 12, 4 can be divided by 4, by 2. Likewise, 9 can be divided by 9, by 1, and also by 9, and also by 3. Likewise, 35 can be divided by 5, can be divided by 7, can be divided by 35, and also by 1. That means these composite numbers have the factors other than 1 and the number itself. Now, in both the cases, whether it is prime number or in composite number, prime number starts with 2 and composite number, the smallest composite number is 4. But what about 1? 1 is neither a prime number nor a composite number, because as per the definition of the prime number, the number can be prime only if it has two factors. They are 1 and the number itself. But 1 has only one factor, 1. No other number can be taken as a factor of 1. It is because of this reason 1 is neither a prime nor a composite number. Let's see some example. Explain why 3 into 5 into 7 plus 7 is a composite number. The given number is 3 into 5 into 7 plus 7, which is nothing but 112. Now, if we do the prime factorization of 112, we are getting it is 2 to the power 4 into 7. That means it is clear that 112 has factors other than 1 and the number itself, and the factors are 2 and 7. 2 and 7 are the factors of 112. So we cannot say this 112 or the number so formed by 3 into 5 into 7 plus 7 is a composite number. Hence 112 is a composite number. Is the answer. Check whether 4 to the power n, where n is a natural number, can end with the digit 0 for any natural number n. Even n is a natural number, let us assume that 4 to the power n ends with 0. So 4 to the power n is divisible by 2 and 5 both, because 2 into 5 is 10. So any number which is divisible by 2 and 5 both, that particular number or any power of that particular number ends with 0. Now let's see what is the prime factorization of 4. The prime factors of 4 is 2 square. So 4 to the power n is 2 to the power 2 square to the power n, or it is 2 to the power 2n. Thus, the prime factorization of 4n does not contain 5. So, our assumption 4 to the power n ends with 0 is wrong, because it contains only 2 but not 5. So, there is no question of 0. Hence, there is no natural number n for which 4 to the power n ends with the digit 0. HCF and LCM by prime factorization. Let us find how to get HCF and LCM of the by doing the prime factorization. To get HCF or LCM of the given numbers through prime factorization is to do prime factorization of each given number separately. Now HCF or highest common factor of two or more numbers is nothing but the product of the smallest power of each common prime factors involved in the numbers. If there is no common prime factors, then the HCF of the given numbers is 1. That means what I need to do to get the HCF, first of all we have to do the prime factorization of all the numbers, and after getting the prime factorization of all the numbers, the HCF will be the product of the smallest power of each common prime factors involved in the numbers. That means there should be any common numbers, and for HCF we have to take the least power, smallest power of those common numbers. And if there is no common prime factors, then the HCF of the given number will be 1. Now LCM or least common multiple, LCM of two or more numbers is nothing but the product of the greatest power of each prime factors involved in the numbers with highest power. Let's see some example. Find the HCF and LCM of 612 and 1314. So the given numbers are 612 and 1314. By doing prime factorization, we get 612 to be equals to 2 square into 3 square into 17, and 1314 is equal to 2 into 3 square into 73. So here, if we take the common factors, 2 is common in both the cases, but in 612 the highest power of 2 is 2 square, but in 1314 the highest power of 2 is 1, that is 2. 3 is also involved in both the cases, and the highest power, or you can say the least power, the smallest power of 3 in both the cases is same, that is 3 square. 17 is involved only in one case and the highest power is 1. Likewise 73 is also involved in only one case and the highest power is 1. So it is clear, if we go by the definition, HCF is nothing but the smallest power of each common prime factors involved in the numbers. That means if we take HCF, it is nothing but 2 into 3 square. Let's see what is HCF. The HCF is 2 into 3 square, which is equals to 18. Now if we go by the definition of LCM, the highest greatest power of each prime factors involved in there. That means it is 2 square into 3 square into 17 and into 73. Let's see what is the answer of LCM. LCM of 612 and 1314 is 2 square into 3 square into 17 into 73, which is nothing but 44,676. Thus the HCF and LCM of the given numbers are 18 and 44,676 respectively, is the answer. Find HCF and LCM of 60, 84 and 108 by prime factorization. The given numbers are 60, 84 and 108. So by doing the prime factorization, we get 60 equal to 2 square into 3 into 5, 84 equals to 2 square into 3 into 7, and 108 equals to 2 square into 3 cube. So the HCF of 6, 84 and 108 is 2 square into 3, which is equals to 12. And LCM of 6, 84 and 108 is 2 square into 3 cube into 5 into 7, which is nothing but 3780. Thus the HCF and LCM of the given numbers are 12 and 3780 respectively. Let's see the relationship between the numbers and their HCF and LCM. For any two given numbers, say A and B, the relation between HCF and LCM is given by HCF of A and B into LCM of A and B is equal to A into B. That means we can say the product of the HCF and LCM of any two given number is equal to the product of the numbers. Let's see some example. If LCM of 26 and 91 is 182. Find HCF. So the given numbers are 92 and 182. We need to find out HCF, and the LCM is given as 182. So as per the relationship, it is HCF of A and B into LCM of A and B is equals to A into B. Let's put this number into this relationship. So we can write HCF into 182 is equal to 26 into 91, or HCF equal to 26 into 91 whole divided by 182, which is nothing but 13. So the HCF of the given numbers is 13 is the answer. If HCF of 253 and 440 equals to 11, and LCM of 253 and 440 is equal to 253 into R, find the value of R. Given numbers are 253 and 453, 440. The LCM, given that HCF is 11 and LCM is 253 into R. Now we know HCF of A and B into LCM of A and B equals to A into B. So we can write 11 into 253 into R equals to 253 into 440, or we can write R equals to 250 into 440 whole divided by 11 into 253, which is nothing but R equals to 40. Hence, the value of R is 40 is the answer. The length, breadth and height of a room are 8 meters 25 centimeter, 6 meters 75 centimeter, and 4 meters 50 centimeter respectively. Find the length of the longest rod that can measure the 3 dimensions of the room exactly. Given the length of the room is 8 meters 25 centimeter, or let us convert into centimeter, it is 825 centimeter. Breadth of the room is 6 meters 75 centimeter, which is equal to 675 centimeter, and width of the room is 4 meter and 50 centimeter, or we can write it as 450 centimeter. To find the length of the longest rod, we need to find out the HCF of 825, 675 and 450. So by doing the prime factorization, we get 825 is 3 into 5 square into 11, and 675 is 3 cube into 5 square, and 450 equals to 2 into 3 square into 5 square. So HCF of 825, 670 and 450 is 3 into 5 square, which is equal to 75. Hence, the record length of the longest rod is 75 centimeters. Is the answer. Friends, here is a few examples, few questions. The more and more such questions you practice, the more you like it and the easier it becomes. So friends, practice more and more such questions, and in case you come across any difficult question, please feel free to share your question with me. It will be a pleasure for me if I can help you out in solving your doubts and solving your question. So this much for today's class. Thank you.